Hi, this is I have a total of 18 plus years of experience in information technology. Currently, I am working as a principal software engineer in Liberty Mutual Insurance. Today, I am going to talk about how ML driven Slack integration cut mean time to resolution by 88.5% across 17 enterprise systems. Now, we are going to talk about the problem. Enterprise applications processing millions of daily transactions generated an overwhelming volume of errors and alerts. This led to critical issues being buried in noise and severely impacting our operations. With manual monitoring across 17 production systems supporting over 230,000 daily active users, our teams faced significant challenges, which are mentioned below. Slow average detection times of 162 minutes, a staggering 68.2% of critical issues discovered first by customers. After hours, incidents averaging a prolonged 131 minutes to detection. SLA compliance plummeting to a mere 62.3%. This slide we are talking about the agenda, the challenge alert fatigue. Understanding the pervasive issue of alert fatigue and its enterprise wide impact. The ML solution architecture slide is going to talk about designing a robust middleware system for efficient and low overhead exception capture. The intelligent alert orchestration talk about leveraging ML for context aware routing of critical alerts to optimal channels. The results and business impact slide is going to talk about demonstrating quantifiable improvements in mean time to resolution, cost savings, and developer productivity. The implementation guides is going to talk about practical MLOps patterns for deploying your own intelligent error monitoring system. The challenge alert fatigue, the hidden cost of scale. Our 17 enterprise systems were generating 230K plus daily active users, 3.7 million daily transactions, 12K plus daily error events, 860 plus daily alerts. On the right hand side, we have represented the operational impact. The mean time to resolution is represented in minutes. The customer reported issues are represented. The SLA compliance percentage is represented on the right hand side. Alert to action ratio. This alert overload meant engineers spent 23% of their time triaging alerts, diverting crucial effort from building new features and resolving core issues. Next, we are going to talk about the ML solution architecture. Middleware system capturing exceptions with minimal overhead. The key technical specifications 99.7% of exception capture rate across all systems. Only 3.2 milliseconds overhead per transaction. Distributed tracing for context preservation. Event driven architecture with Kafka backbone. Containerized ML interference endpoints. The ML classification models 93.8% of accuracy in prioritizing errors by business impact. Ensemble approach combining random forest for categorical features, LSTM for stack trace analysis, gradient boosting for time series patterns, continuous retraining pipeline with human feedback. The ML model features what makes an alert critical. We have divided into four categories. The exception characteristics is the first category, the stack trace pattern matching, exception type classification, message semantic analysis, code path frequency. The next category is business context based on affected user count estimation, transaction financial value, business process criticality, data integrity impact. The temporal patterns is the third category based on the time of delayed correlation, error frequency trends, business hour weighting, seasonal pattern matching. Based on the historical response, prior resolution times, SLA breach prediction, historical escalation rate, developer response patterns. Models are trained using 18 months of historical incident data encompassing 12,387 resolved incidents with complete resolution workflows and outcomes. This slide is going to talk about intelligent alert orchestration, the adaptive routing, getting right alert to the right person. Contextual evaluation is means each alert is evaluated across 14 parameters, including severity, system impact, time of day, and team workload. The ML decision engine leverages ML to determine the optimal notification channel and urgency level based on predicted business impact. The channel selection routes alerts to the most appropriate channel, Slack direct messages, Microsoft Teams, or email based on context and urgency. The alert delivery formats alerts with actionable information and includes severity, appropriate urgency signals. The intelligent rate limiting. Our ML powered rate limiting algorithms effectively prevented alert storms during major incidents, achieving 68.2% of reduction in overall alert volume during incidents, 99.8% detection rate of unique issues maintained, automated clustering of related errors, predictive suppression of cascading failures. Now we are going to talk about the results and business impact. The transformative results across the enterprise. On the left hand side, we have represented the key performance improvements. On the right hand side, we are going to show the tangible business impact. 88.5% of mean time to resolution reduction, $2.3 million of annual savings, 23.5% of developer productivity, 73.4% of alert volume reduction. The mean time to resolution is decreased from 162 to just 18.6 minutes. We are able to get $2.3 million of annual savings is achieved through reduced downtime and enhanced operational efficiency. 23.5% of developer productivity is boosted by significantly reducing time spent on alert triage, 73.4% of alert volume reduction resulting from intelligent clustering related issues. Now we are going to talk about the key takeaways and implementation guide. On the left hand side, we have represented the MLOps best practices. Start small, scale gradually, begin with one high volume system and expand as models mature. Human in the loop feedback. Create explicit feedback mechanisms for continuous model improvement and accuracy. Measure the business outcome. Focus on mean time to resolution and cost savings, not just model accuracy metrics. Build for transparency. Ensure engineers understand why an alert was triggered and how it was processed. Your implementation journey is represented on the right hand side. Secure data foundation. Implement robust exception capturing with minimal overhead and distributed tracing across all enterprise systems. Model training and validation. Curate historical incident data for training and continuously validate ML classification models. Orchestration integration. Connect your ML engine to intelligent routing and notification channels like Slack, Teams, and email. Iterative development. Roll out the solution incrementally, gathering feedback and refining the system with each iteration. Thank you.